Good morning, fourth graders. This is Mr. Peters with your first lesson on virtual learning for math. Today we're going to be working on area and perimeter problems. In particular, you will use your student book pages 224 through 226 for this problem. Today's goals, we're going to be working with multiplying two-digit numbers using strategies, being able to divide 2 or 3-digit numbers by a 1-digit number using base 10 strategies, properties or operations, and then also being able to apply the area formula for a rectangle to solve a problem. Some of the terms that we have been working with would be area, dimension, dividend, division, divisor, length, perimeter, quotient, and rectangle. Remember, the area is the two-dimensional space that a shape takes up, and that the perimeter is the measurement around the area. As you can see here on our diagram, area is in the middle, perimeter goes around it. So for our first problem today, we have two fourth graders. They started solving the same problem in two different ways. Can you figure out what problem they are solving? Identify and complete the models they used to solve the problem. So for student number 1, here's the work that they had started with. And so what I want you to do is take a minute to look at this and see if you can figure out what is the problem that they are trying to solve. So if you notice, we have 1, and then we have 3, 5, 15, 10, and 30. What would be the problem that they'd ultimately be trying to solve for the student? You can pause the video at any time to do your thinking. Then down here, we have another student solving the same problem, but using a different strategy. So this student is using our area model versus a ratio table. And so you can see that this student has their 3 times 100 is 300. But then they go down to the 450. So what would they have done to solve this problem here? Once again, take a minute here to discuss if you have the opportunity with somebody, or just pause the video to do your thinking here. So on this one, on the top, let me bring up our screen so we can focus on this. If we're going to continue a ratio table, remember we want to try to use big friendly jumps for it. And so if we notice, we have 1 to start, and then we go to 3. So they're clearly multiplying by 3 each time. And so if we took our ratio table here, we could continue on and build it up. And so if we wanted to, well, we tried 10, so we might try even going up to 100. And so if we have 100 times 3, that will give us a total of 300. Now what we should be asking ourselves here is how much more do I need to go from 300 to 450? And so if you were doing that, you would recognize that it's 150. And so your question for yourself is 3 times what is equal to 150? And so if we put in 50 here, solve our problem. And if we put 50 in there times our 3, that is 150. You can also notice the connection that we cut the 100 in half. So we cut our part of 300 in half. Okay. Now, once we add these together, we would get up to our total of 450. And so if we add those parts together, what we're really adding together would be up here, 100 plus our 50 equals 150. And so this student would have used the area model. Now they could have continued with smaller jumps all the way up to the 450. But like I said, we really want to try to do big jumps. And so we start with smaller ones and gradually try to get a little bit bigger using some friendly numbers along the way. Now for this student down here, student number 2, they were using the area model. And so if you remember on the area model, the whole interior is what our area is. So on this rectangle right here, we have 3 times 100 is 300. And then if you notice, we are still missing that 150. So we're trying to figure out 3 times 50 equals 150 for a grand total, once again, to where our arrows are, of 450 there. So that's the work that you would be doing with this problem. So you can solve it two different ways, using your ratio table and building up with big friendly jumps, or using your area model and trying to do larger chunks here as well. Now, one of the key things with the area model is, or with the ratio table, I'm sorry, is to remember that you only add up. So our 300 here and our 150, you only add this part to get your total, because 300 plus the 150 is your 450. So our answer, oops, and I miswrote it over here, I'm sorry, is actually 150 here for you. I'm sure many of you saw that before and were like, Miss Peters, come on. Here you are. Okay, so once again, pause it anytime you need to go through the work and see what it is that we are working on there. Now, before we continue, we want to just talk about some of the units that we use to measure area. And so we've worked on these in the past. And so I want you to pause the video here for a second and try to brainstorm some of the units that you might be using. All right. So some of them that we could be using would be things like square feet, square inches, square yards, square miles, square centimeters, square meters, and square kilometers for kilometers. And then we have our abbreviations, the SQ feet, SQ inches, and so on. The big thing to remember is that whenever we're measuring area, we measure it in square units. And that would be whatever your first unit was that you're measuring your length in. So if you're measuring in feet to start with, you get your area in square feet. If you're measuring in yards, it's square yards. Now, one of the other ones that I want to show you here is that if you're doing square feet, you could also write it as FT and then put your 2 up there. Some of us do that as well. And that would work out as well, because the 2 up there shows that it's multiplying the same number twice. And so that's what square means for that one. What might we measure in some of these? So sometimes it's hard to imagine if we're not familiar with some of the units. What are some of the things we might measure? So I want you to pause and think about the idea of a centimeter, and then the idea of a foot, then meters. So we're getting a little bit bigger, then miles. And I want you to pause and think about some of the things that you might measure in square centimeters, square feet, square meters, and square miles. So pause the video and try to make up a list for yourself. Either write it out or keep it to yourself in your head. All right, now I have it back here. Some of the things that we might have here would be area of a book cover, bookmark, or piece of paper. Those are things that we might measure in square centimeters. Once again, a centimeter is a relatively small unit of measurement, and so that's why we would be able to measure that in square centimeters. An area of a rug, a sandbox, or a wall. So if you think about the rugs that we have in our classrooms, those we'd measure in square feet. You count out a few feet wide, about 7 feet wide, times 10 feet, the rug would be about 70 square feet. Now, once again, we could get even bigger and have the area of our playground, a swimming pool, or a supermarket. Those are all things that you might actually measure using square meters or square yards. And then if we got even bigger, you'd measure the area of a city, a state, or a country in square miles. And so remember, each square mile is 1 mile by 1 mile wide. And so that's how you'd get your square mile. All right, so this one we're going to do together, but I want you to be solving it in a math notebook if you have yours. Otherwise, find a piece of paper just to do your work on will be okay as well. So a certain rectangle has an area of 252 square meters. This rectangle is 7 meters long, 7 meters wide, I'm sorry. How long is it? And we're supposed to make a sketch that shows what you know about this situation. So take a second to make your sketch. Please pause the video. All right, so what do we know? Well, first we have a rectangle, and we know that one of the sides is 7, and that the area is 252 square meters. Okay, Now write an equation that represents this problem. So once again, if you remember our area equation that we have length times width equals area. So we are given the width of it, which is 7, and we are given the area, which is 252. And the part that we are missing right now, sorry about that, is our length. And so right now we need to figure out what that L would stand for. So something times 7 equals 252. And on the next page here, I'm going to show you some of the strategies that we can use. So I want you right now to try using an array or ratio table to solve this problem. So if you're in the classroom right now, this would be your opportunity to practice with a partner or on your own while the teacher is walking around. So I want you to be doing that for yourself. You can pause the video at this time. Okay, now that we have you back, we're going to be working on this problem. So if we go back quickly here, we see that we had 7, and then we're going up to 252. So our target area is 252. And if you remember, we're trying to figure out what L is. So I'm just going to put 1 in here because remember, we're multiplying that side times 7 each time. So if I put 1 in there, I'm going to do 1 times 7, which is 7. So each time that we're multiplying our length, we're going to find our meters. So we're multiplying by 7 each time. So if I did that and I wanted to build up, I do 1 times 7. All right, I'm going to go up to 10 because if I know my 1, I know my 10. And that's going to become 70. And I could double that. Doubling is a nice, quick, friendly way to go about doing this. And we get up to 140. And now I'm going to ask myself, can I double that again? And if I did, I would get up to 280, which would be too big. So instead of doubling it, I'm going to put my 10 and my 20 together, and I'm going to try 30. So if I tried 30 for my length, the area, 70 and 140, would actually equal 210. And so right now I want to be asking myself, how much more do I need to get up to 252? And so since I have 210, I need 42 more to get up to 252. Now, if we are using our multiplication facts, we could figure out that there's a connection between 7 and 42. And so that number is actually 6. 6 times 7 is 42. So now, once again, like I said with the ratio table earlier, you want to be careful. Make sure you don't add everything up down here on the bottom. You want to make sure you only add what you need. So if I do 30 plus 6, that's going to obviously be 36. And then if I did my 210 plus my 42, that gets me to my 252. So this part, my total is 36, which I get right here. And then this part, my 210, my total is up to 252. So what that tells me is that if I kept my width of 7, my other side that I multiply by, 7 times 36 would total up to 252. And now I'm going to show you quickly how to do it with an area model or an array. So with this one, we're really asking ourselves, 7 times blank equals the area of 252. So we're trying to build up the center of our rectangle here up to 252. So I'm going to just erase this for a second while I do the work. And so once again, we're going to try to do big friendly chunks. And so this is where we can build it up. So if I did 10 here, then this part of the rectangle would be 70. I could do another 10. That'd be another 70. And then another 10 gets us another 70. And so if you remember from our problem before, we're up to 210 now. And once again, the part that we still need to add on is 6. Now, when you do your drawings, your area won't necessarily be exactly perfect. The more important part is how you label it. So if you notice on this top side, well, first of all, sorry, our area, if we do 70 plus 70 plus 70 is 210, plus our 42 is 252. And once again, that would be meters squared. Now the other side, because if we go back to our question, we were asked how long is the other side? How long is it? So we want to figure out, we had 10, 20, 30, plus our 6. The total of this other side is 36 meters. Okay? So what we want you to do as our 4th grade teachers here, we want you to figure out which one of these strategies really works best for you and try to use that one. And still understand that you can use the other ones to double check your work, because we still want you to be able to solve problems both ways. So now it's your opportunity to show your work. And so we're going to ask you to do student book pages 224 through 226 for these problems. Once again, read the problems carefully as you do it. Make your sketch, write your equation, and then show your work. That's so important on here. And I'll encourage you once again and remind you that the people who created these problems, they didn't just pick them for no reason. They gave you an opportunity to work a little bit smarter or a little bit more efficiently. So if you notice on some of them, for example, the 693 is the area, and the one side is 7. You're trying to figure out 7 times something equals 693. You could find a more efficient way to solve this problem. Same idea down here, this problem here, we have a bike trail, 7,147, and then it's 7 feet wide. So you can use some big friendly jumps there. You don't want to do little jumps on these problems. Once again, here are the ratio tables and arrays that you can do for practice on these. Once again, if you have any questions about these problems, please feel free to reach out to any of the 4th grade teachers here. We are still here to help you guys. We love you guys. We care about you guys. So feel free to reach out to us. Once again, rewatch the videos if you need to as well. And good luck with your work. And please try your best and keep working hard. We know you guys can do it. Thank you.